point out that.
Professor?
Yes.
Got no negative.
Oh, okay. Thank you very much. This kind of help I need. So in this case, the e sub x equal to minus dvx dx. Suppose a function, voltage function is free coordinate, including x and y and z. Then in the future, you will learn if v is a function of x, y, e, of x, y, z. In these cases, then we need the partial derivative. So in these cases, the e sub x is a partial derivative of e and partial derivative of x. So ex is equal to minus partial derivative of v partial derivative x. This is only around x direction. Suppose we like to talk about in the y direction, you do the same thing. So ey is equal to minus partial derivative y, and zz is equal to partial derivative of v divided by partial derivative e. So that is composed of the three dimension or derivative, and we done that. So after we talk about this one, then we have another important to talk about.
What's that symbol?
It's partial derivative. It's the derivative of calculus.
I'm sorry, you haven't learned it yet. He learned it already. How far you go in math?
Finish all the calculus.
Huh?
Only finish up to 5C.
I see a partial derivative.
Yeah, I also had integration and transformation.
Okay, when you do the in our case, in our problem, we just involving partial. Or partial means that if the v is a function of x, y, z, when you do derivative respect to x only, then what happened to y, what happened to z, you treat it as constant. So when you derivative of v respect to partial derivative of y, all the x and z you consider constant. And so that applies to the rest of the situation. So then in the electrical type of problem, in generally, besides deal with the single charges, and then what happens to a medium have a multiple charges? In that case, you have to consider the multiple charges on a surface or on a solid. In that cases, you might have to do the integration. So that is the reason why when we're talking about this Physics 31B class, I try to not to scare you off, start with optics first, rather than the electrical. Usually the electrical, the first midterm electrical exam, 50% is average. Okay, so basically it is 250 points, is 50% of students get below 125 points because it's an evolving integration involving different concepts. So in these cases, we are talking about the electrical potential. The electric potential due to continuous charge distribution. So what we have here is a body or an object have an electrical charge here everywhere. Little QE here. Then if these charges depend on the shape, depends on if it's solid body, then it's a charge per unit volume. If it is only about area, then it's a charge per unit area. So in this case, a point in here is called dV. And here to here is dq, small charges, and the point in here is r. So then dV is equal to ke dq divided by r. So then you have to integrate about the voltage due to all the charges there, and you do the integration of dE integration dq divided by r. So this is the case. So now we have a lot of problems related to this. For example, suppose a ring have a charge on it. A ring have a charge on it. So in generally, we have a lot of similar problems like this in the mechanics. For the electrical problem, we have a ring of charges. This here have a ring of charges. In these cases, we have a small segment here, is dq. And especially here is influenced by a segment to the electrical spark right here. So this is a point P. So the electrical charges is in this direction. Now this is a ring. So if it's a ring charges, then you can say that dq is related with this circular element. So you do the integration. This one presented to you is on example 20.5. Now we have a similar problem in the gravitation. This is electrical voltage, electrical potential. We usually call voltage. And then we have gravitation is the same thing. Gravitation. We have similar problem like that. You have a circular ring, circular mass. So what would happen in here have a point. Again, this is a dm, and then to here. Suppose here is m1. So what would happen like a force, the electrical force, gravitational force. Now, why we pick this have a symmetry? So when you deal with this kind of electrical potential problem, looking at symmetry. So this is a symmetry because this component, E component, have an X direction and Y direction. And there's another one similar like this, go through, have another component, E component on the Y direction and E component in the X direction. So you have to define here is X direction, here is the Y direction. So due to the fact E sub Y in one component in here, another one is go with this component, they cancel each other. So by doing that, there's only the electrical field or the voltage only along in the X direction, especially electrical field. Electrical field is only along EX direction. And another one, in which case this is a very good, and I consider as a very, very good problem. In which case they consider solid charges, a solid sphere have charges on that. A solid sphere